Hello, we're starting section 7.7 on conditional distributions. The goal of the section is to define the conditional distributions for two jointly distributed random variables and to use them to calculate conditional probabilities. As motivation, we're going to recall the definition of conditional probability for two events from your first probability course. Definition 7.7.1. If A and B are events, then the conditional probability of A given B is the probability of A given, that vertical bar means given, B is the probability of A and B divided by the probability of B. And in a Venn diagram, the conditional probability of A given B can be represented as follows. So if we have the universal set or sample space S, if we have sets inside A and B, then the idea here is that we are restricting ourselves to B. If you know that you are given B, that means B has occurred. And if you want the probability of A given B, then you want the part of A that's within B. In other words, you want this, right, A intersect B, as a ratio to the likelihood of B. In other words, the probability of A given B is exactly this probability here, which is the numerator of our fraction. So that's the probability of A and B as compared to the probability of the set B. So as the probability of B. So there it is represented diagrammatically in a Venn diagram. In the next video, we'll see an example which also gives us a bit of a motivation, and then we'll actually define the conditional distribution in the discrete case for two random variables x and y.